Okay, this video is actually probably going to break into two videos, maybe even three, because of the amount of content that we're discussing. We're going to deal with slope of a line. And along with that, we're going to go through finding the slope of a line, the slope-intercept form, and recognizing positive, negative, zero, and no slope from a graph. You'll see as we go through this, if you're finding the slope or you have something in slope-intercept form, you'll know if it's positive, negative, zero, or no slope. But we're talking about recognizing that if you just have the graph, if you don't have the numbers. So we're going to start here with slope of a line. And what is the slope of a line? Well, if we just have a line like this or this, slope basically tells us how fast is it going up or going down, or basically moving. Basically, slope just tells us how steep is the line. If this was a hill, how steep is the hill? That's basically all that slope really changes us. And slope is written as a ratio of vertical change to horizontal change, if you want to look at it in a complex way. But basically, it's written to say in a ratio of what we call rise over run, which is how fast is it going this way over how fast is it going this way, which you can also have vice versa, down and left as well. But if we get more into finding slopes and seeing slope-intercept form, we'll get into more of that. That's, again, just a little brief introduction interview. So anyway, just the slope of a line basically tells us how steep is this hill. So if you want to find the slope of a line, I'm just going to abbreviate this as finding line slope. So I don't spend the whole video writing. So I'm going to make myself a little graph here. Excuse me, this is why my drawing is terrible. This is why my major is math and not art. So you got your x-axis and your y-axis. Little arrows to indicate those lines go on. And we're just going to plop a little line in here. So a little line. We're going to just call it line Z. It's not really important, but just so we have something to call it, to refer to it by. And we're going to put a couple little tick marks in here. Green's a good color. We'll call that 1, 2, 3, just like your typical -2, -3, -1, -2, -3, just like a regular graph. So if we look at some points on this line, and this is figuring slope given points on a line. Let me make a note of that. Finding slope with points on the line. Okay, so when you've got a line like this, not giving you anything about it except some points on line Z here. So we're going to look at line Z and find some points on here. And points are expressed as two coordinates, an x and a y, which all that does is tell you where on the x-axis, if you drew a straight line down from this 1, 2, 3 or whatever, where it would hit straight up or down, and where on the y-axis it would hit if you drew straight up and down, or straight left and right. So we'll come over here and set up a couple of coordinates, because you have to have at least 2 points on a line to calculate the slope from points on the line. So we're just going to pick a couple of random points. Let's say we'll just take this one right here, which is 1, 1. And this one right here, which is -2, -1. I'm sorry, -1, -2. The x is always written first. Alright, I'm going to write my x numbers I guess I'll write them in blue. So, this one we established our x, so we come right up here from 1 to our dot. It's 1. And here we come right from a -1 down to our dot, so it's -1. And then we also have to have a y coordinate. So we look straight over from the dot here to 1, and so we know these two numbers go together. And then we look straight over here, and we know that's -2. Now, what does all that tell us? Well, now it pretty much just becomes a matter of subtraction. So that tells us, the distance we're covering between these two. So we're going to take our blue numbers and subtract them from each other, and our magenta numbers and subtract them from each other. I know it really is probably purple, but it kind of looks magenta-y to me. So 1 minus -1 gives us an answer of, trying to find a good color here, 0. And then 1 minus 2 gives us an answer of -1. Now this line is not drawn to scale, so this slope is not going to wind up being correct. So let me choose a different point on the line. I was afraid that was going to happen when I started looking at it. Let's choose a point a little further out for this point, and we'll change up our numbers a little bit, because like I said, since I didn't draw this really to scale, I don't get a good reference. Now 0 divided by 1, anything divided by 1 will give you 0. This is not a zero slope line though, but again, if this was drawn nicely to scale and you got good numbers, this would work, because this is not there is such a thing as a zero slope line, but this is not a zero slope line. So we'll do another one with some different numbers and the drawing to a different scale. Got my y-axis and my x-axis. This time we're gonna kind of blow things up a little bit. So that's 1. This is 2. This is 3. -1, -2, -3. So things space out a little bit better, and you can actually see a little bit better. -2, -3. We're going to have 1, 2, and 3, and then our -1, -2, -3. So let me get in here and draw line Z again. Make it pretty steep. Okay, and this is our line Z again. So now we're going to grab a couple of points on line Z. And so I'm going to take this point right here. That's going to give us one point and another point. And I'm going to pick another point right there. Now let's see what we get this time. So this point is -1, so as we came up from the x-axis, and 2, +2 as we come over from the y-axis. Our other point, if we look here, we come over from the x-axis first, and it's going to be about 1.5. So, and -3. Again, since it's kind of rough and not to scale. So now we're going to subtract the blue numbers from each other and the purple numbers from each other to give us a ratio. So we're going to put a little bar in the middle, and we're going to put the result of our blue numbers here on top, because we want a ratio we can express as a fraction, so that's what we're going to do. -1 minus 1.5 gives us negative 2.5. Then 2 minus negative 3 gives us negative 1. And I happen to know that looking at this is a negative slope line. So that's why we're coming up with negative numbers. This negative over a negative, though, should be a positive. Again, without being to scale, it makes it difficult to make your numbers come out right. This shows this a ratio between these two numbers, though. So when you divide it out, you get the actual slope, although slope can be expressed like this. When you divide it out, you get 2.5. Or actually, should actually be negative 2.5 because this is a negative slope line. Like I said, I wish I had a graph where I could actually draw everything out to scale. And make it come out looking nice. So what we'll do in the next part of the video, I'm going to split this one up because it's got a lot of content, is I'll draw a better example with that, but we'll also look at, let me give you this formula that we'll look at when I'll come back with a better example in the next video. M represents our slope. Why they picked M to represent slope, I don't know. And M represents, well, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now you're saying, where do I get y sub 2 and y sub 1 and x sub 2 and x sub 1 from? Well, when you get your points, when you're given your points in your line, you have your points of x sub 2, x sub 1, and y sub 2, y sub 1. So, like I said, we'll do another example in the next video. Hopefully it'll be drawn a little bit better. The freehanding is kind of killing us on this one. So, but I'm going to go ahead and cut this one off here, and we're going to discuss our next 2 points, which are identifying the slope from just looking at it if we know it's positive or negative. Slope just from looking at it, as well as looking at slope-intercept form. So I'll put a link to that next video in the description. Thank you for watching.